Hello everyone. Let us discuss a topic on investigating the scalability of the content-centric networks. Abstract. This work addresses the limitations of traditional TCP or the IP networks in handling the exponential growth of the IoT devices, including the issues like the traffic congestion, address space, scalability, scarcity, and inefficiency. Information-centric networking had emerged as a solution, emerging in the network caching to improve the performance by storing the content at intermediate nodes. However, most existing caching strategies use the basic content replacement policies like the FIFO, LRU, and LFU, which ignore the crucial content attributes and can lead to the eviction of the important content. The study proposes a novel content replacement scheme that improves in the network caching by recording the number of requests and the access times in pending internet table. This scheme takes into an account key content attributes such as the number of requests remaining lifetime and upcoming request waiting time before deciding to replace the captured content. Simultations using the NDN SIM framework on the NS3 were performed to compare the proposed scheme with existing strategies. Results show that the proposed scheme improves the performance significantly with a 28.94% increases in cache hit ratio, 27.49% reduction in the server hits, and reductions of 22.30 in the response delay and 30.64 in the energy consumption compared to the NDN FIFO, NDN LRU, and the NDN LRFU. This demonstrates the scheme potential for enhancing the efficiency and performance of ICN in the IoT networks. Introduction. This work explores the challenges posed by the rapid growth of the IoT devices, particularly regarding the data traffic and scalability issues in the IP-based networks. It presents information-centric networking as a made suitable solution for the IoT, offering the advantages like the fast data retrieval, content-based security, and in-network caching, which helps reduce the traffic, energy consumption, and response delays. Named data networking, a key ICN for the key ICN enhances the IoT networks by catching the content close to the subscribers, but traditional replacement policies like the first in, first out, least replacement, least recently used, and the least frequently used fall short in addressing the transient nature of the IoT data. Simultations conducted using the NDN SIM framework demonstrated significant improvements. The proposed schema achieved a 28.94 increase, a cache hit ratio, 27.49 server hit reduction, and reductions of 22.30 in response delay and 30.64 in the energy consumption, outperforming the traditional replacement schemas like NTN FIFO, LDN LRU, and LDN LRFU. In conclusion, this replacement schema improves the IT network's efficiency by optimizing the network caching, making it a more adaptable to the fast evolving and the traffic heavy to the IoT landscape. Background and the related work. In the ICN based networks, network performance is influenced by both caching strategies and the cache replacement policies. Caching strategies determine what data should be cached and in which specific location or the node within the network. While cache replacement policies manage which data should be evicted once the cache is full. Section 2.1 provides a detailed overview in the existing caching strategies and the replacement policies, explaining their role in the optimizing the content storage and retrieval within the network to ensure the efficient data management and improve overall the network performance. The network performance depends on both, that is, cache strategy and the cache replacement policy used. The decision of what data to catch and in what particular location or the node of the network is particularly in the network of caching strategy. The cache replacement policies deal with what data item to evict from the content store once the cache is full. The existing cache strategies and the replacement policies for the ICN-based networks are comprehensively described in the sections 2.1 caching strategies. Design. The proposed scheme is designed in the four key steps: calculating the key matrices, proactive tracking, estimating the remaining lifetime, calculating the eviction value, calculating the key metrics. In the first step, we determine the number of requests for each content item, track how long it has been cached, and note down the access time. Proactive tracking. The second step involves the actively recording the number of requests and how long the requests have been waiting. This helps us keep a close eye on the content usage. Third, estimating the remaining lifetime. In the third step, we estimate how long each piece of the content is likely to remain relevant or leave before it becomes outdated. Finally, the fourth step, we compute on the eviction value for each content item, which helps us to decide which item to keep in the cache and to remove when the space is needed. To support these steps, we have developed four algorithms. Algorithm 1 handles the calculation from the step 1. Algorithm 2 focuses on the proactive tracking. Algorithm 3 is dedicated to estimating the remaining lifetime. And Algorithm 4 outlines the eviction value calculation process. These algorithms work together to enhance the efficiency of the content management within the caching system. We come to the conclusion of this topic. Information centric networking presents a promising approach to addressing some of the challenges proposed by the future internet. One of its standout features is in the network caching, which enables the ICN to efficiently manage the various issues associated with the Internet of Things, including the data availability, scalability, uneven network flows, and reliability. Within network caching, intermediate nodes can store the content, allowing them to fulfill the most subscriber requests directly. This means that many requests can be handled locally, reducing the need for the data to travel all the way back to the original IoT data publisher. However, in the high traffic IoT networks, these caches can they can fill up quickly, making the effective management essential to ensure that the most relevant and the frequently accessed content remains available.